All right, now we're going to learn about independence. This is a pretty important topic that kind of bleeds into a lot of things for the rest of the year. It's the thing, it means that events do not have any effect on each other. So if we know two events are independent, then the probability of A and B, probability of both of them occurring, is these two multiplied together. Uh, that's an important thing to know. So in this next example, the probability the Vikings win a game is 55%. The probability that the Timberwolves win a game is 25%. What's the probability that the Vikings win and the Timberwolves lose? Well, first off, let's draw a nice rectangle to talk about our sample space. And then we can have a couple circles in here representing the Vikings and the Timberwolves. All right. So the probability that the Vikings win is 55%. The probability that the Timberwolves win is 25%. Now, independence. Let's think about it. If Vikings win, does that affect the Timberwolves at all, or vice versa? I would highly doubt that. So then we can use the equation, the probability that they both occur is equal to the probability of Vikings times the probability of the Timberwolves. So if I take 0.55 times 0.25, I get a center of 0.1375. So that's the probability that both of the things occur. Now, if I want to find the probability that the Vikings win, but the Timberwolves lose, that would represent this little spot here. So if I take 0.55 minus that, I would get 0.4125. Or if I did the Timberwolves side, 0.25 minus 0.1375, this is the probability that the Vikings lose, but the Timberwolves win. Now to get the outside of this, let's find the probability that both of them lose. We add up everything in here, and I get 0.6625, and now I subtract that from 1. So on the outside is 0.3375. So now we have all the probabilities in our sample space. Let's figure out the question. What's the probability that the Vikings win and the Timberwolves lose? So the Vikings win is here. The Timberwolves lose is outside of this box. So this answer is 0.4125. Now, answering the question is as important as filling out the, the whole Venn diagram. All right, now it says the probability that John makes a free throw in basketball is 0.45. The probability that he gets an A on AP stats test is 0.75. Assume that these events are independent. Now, using a Venn diagram and a tree diagram, find the following. John does not get an A in an AP stats, but makes a free throw. So if I wanted to do a Venn diagram, if he does not, so this would be getting an A, and this is basketball. So if he does not get an A, it's outside of this, but he makes a free throw, so it's inside of basketball. So to get that, we know basketball, this whole thing adds up to 45%. This adds up to 75%. The 0.45 times 0.75 is the middle, which is 0.3375. If we subtract that from the basketball, 0.45, we get 0.1125 for an answer. So I did that one with a Venn diagram. Let's try to do this one with a tree diagram. The probability that he does not get an A or make a free throw. So in a tree diagram, he has two situations. He gets an A or he doesn't get an A. He makes a basketball shot or he doesn't make a basketball shot. Now, if these are independent, it doesn't matter if A happens or not. These are going to be the same probabilities. So the probability that he gets an A in AP stats, 0.75, so that's 0.25. The probability that he makes his basketball shot is 0.45, so he misses 55% of the time. So if I wanted to find the probability he doesn't get an A or make a free throw, he doesn't do either of those. So that's 0.25 times 0.55. So over here, oops, 0.1375 is the probability that I'm looking for. Now there's another rule about independence is if we're doing conditional things, and we talked about this previously in one of the first lectures, if the probability of A given B is equal to the probability of A, that's another way to show independence. So in this case, if we want to find if A and L are independent, so the probability they get an A or the grade comes from a liberal arts course, there's two methods. We know that the probability of A and B, or maybe in this case A and L, would have to equal the probability of A times the probability of L. This only happens if they're independent. So if you can find this, and they are equal, they're independent events. Or we could find the probability of A given L and see if that equals the same as probability of A. And if both of those are true, both these are equal, then then we can consider them independent events. So first, let's do this left side. The probability that they get an A and it's our liberal arts is this number out of 10,000. The probability that they get an A is 3392 out of 10,000. The probability that's a liberal arts course is 6,300 out of 10,000. And if we multiply those out, 0.3392 times 0.6360, we get a decimal of 0.21573, which is not equal to this. So here we can show a not independent. Now there's another method over here. We know the probability of A already. Now we just need to find the probability of A given L. So given that it's a liberal arts course, 6,300, what's the probability is A? 2142. So 2142 out of 6,300, that's 0.34. And this over here is really, really close. But it is not exactly the right number, but it's pretty close. And over here, you can see they're really close. So they are not independent, but they are very close to being independent. They have to be exactly the same number for independence. So that's that. Hopefully that you can do your homework.